All right. Oh my gosh. Okay. So I asked you guys to do these yesterday. You're going to go through them and make sure that you do them in the same format as I do, right? If you change stuff or you don't put the angle in, you're not going to get the marks. So I did watch some people. Make sure you have LS. Ooh, I need a pen. Make sure you have LS, RS. So left side, right side. Make sure they're on the right sides. So it's funny when people mess them up. And then we rewrite the equation with 210 in it. So this first one should say 1 minus sine squared 210 degrees. Some people, when I was walking around yesterday, weren't putting the 210 in. We were just leaving them as thetas. So make sure you put the 210 in. And then on this side, we have sine 210, cos 210, and then cotan of 210. All right. So, yeah, ruthless. That's not cool. Ruthless is what I call it. Okay. Are you recording? Yep. 1 minus the sine 210. So what's the answer to sine of 210?
-1, 2.
-1, 2?
Real good line.
There's a line. -1/2 squared. And then I get 1 minus a quarter with equal sign. 1 minus a quarter. And then this has to change, so it'll be 4 over 4. Minus a quarter, which is 3/4. And we hope the other side comes out the same. So, sine of 210, once again, is -1 over -1, 2 with a line in it. Is what you told me. Cos of 210 is what? -3 over 2, yeah. And then cotan of 210 is √3, because we can memorize it, or we can say, okay, it's cos divided by sine, which is -3 over 2 times -2 over 1 over 1, right? We multiply the numerators. -1 times -√3 times √3 is 3. 2 times 2 times 1 is 4. Oh my goodness. Same match. L is equals R. Okay, next one. I'm going quickly because you should have done them last night. LS, RS. So we have tan of 7 pi over 6, which is actually the same as 210 degrees. But we don't write 210 degrees because it didn't ask us to verify 210 degrees. It has to verify 7 pi over 6. And then on this side, we get 1 minus cos of 2 times 7 pi over 6 over sine of 2 over 1, technically, times 7 pi over 6. So I'm going to work with this side first. Tan of 7 pi over 6 is sine of 7 pi over 6 divided by cos. So it's going to be -1/2 divided by -√3 over 2, which is -1/2 times -2 over √3. So you end up with 1 over √3, which rationalizes to √3 over 3. So on this side, I get √3 over 3. The next one lies a problem, because we need cos 2 times 7 pi over 6. So people think that that means find cos of 7 pi over 6 and times it by 2. No. So off to the side, we have to go cos 2 times 7 pi over 6. So technically, we're finding the double angle of 7 pi over 6. So that works out to 14 pi over 6, which reduces to what? 7 pi over 3. Which is too big. We agree? Like it's just outside of the unit circle. Basically, if it was 210, it's now 420. Correct? It's the same thing. So this is actually the same as cos. Take 7 pi over 3 minus 2 pi, which is going to get me a 3 on the bottom and a 6 on the top. So that's 7 pi over 3 minus 6 pi over 3. Coterminal with pi over 3, right? So it's going to be a half. Right? Could you also type cos 2 times 7 pi over 6 in radian mode in your calculator? Yep, try it out. Make sure you're in radian mode.
I am.
And then go cos 2 times 7 pi over 6. What? What do you get? 25. Same answer, because that is the answer, right? So we get minus a half. Now this one, we get sine of 7 pi over 3 is technically what it's going to be. It's the same as sine of pi over 3, which is root 3 over 2. Root 3 over 2 is 0.8660, blah, 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 correct? So type in sine 2 times 7 pi over 6 in radian mode.
I'm so unbelievably mature right now. Are you tired?
We're recording. So we get a root 3 over 2 on the bottom, right? 0.866 when typing in our calculator. We need to make a full fraction divided by a full fraction. You cannot flip the root 3 over 2 until the whole numerator is a fraction. So if you guys learn that, you'll be so good in this unit. You have to have a full fraction numerator and a full fraction denominator before you're allowed to invert and multiply. Currently, we do not have that. So we can change the 1 to 2 over 2. 2 over 2 minus a half. Or you could say 1 minus a half is a half, correct? So we get a half divided by root 3 over 2. Now can I flip them? Yes. I have 2 over root 3, which equals 1 over root 3. Which some people say they match. Nope, they don't. My daughter would not know that that's the same thing. Root 3 over 3. LS minus R. Okay? Next page. So here we get 1 minus cos x over sine x equals sine x plus 1 over cos x, and we're using 120. So I do 1 minus cos of 120 degrees over sine of 120 degrees. These I don't even have to do off to the side because those you can just pull off your unit circle. And then this would be sine of 120 degrees over 1 plus cos of 120 degrees. So here we get 1 minus what? What's cos at 120? What's cos at 120? What's, yeah, negative half. And then what's sine at 120? Root 3 over 2. Am I allowed to flip that root 3 over 2 currently? No, because I need a full fraction numerator over a full fraction denominator. I cannot do the flippy. Okay? So if I want to, I can keep working on this side. This will become a 2 over 2. And this is a minus, so it's actually a plus. So 2 over 2 plus 1 over 2 is 3 over 2. Now I can actually put this beside it. Root 3 over 2. And now I can actually flip it. 3 over 2 times 2 over root 3. And I get 3 over root 3, which I can rationalize. And it equals 3 root 3 over 3, which is just root 3. As long as they can rationalize in their head that you can go from here to here, sure. I would not say that you can go from 3 over 2 times 2 over root 3 and say that's root 3. That would be too much.
Yeah,
But like
I mean, I meant just
from here to there, totally. Just not from that previous hacker step. Yeah. Then sine of 120 is root 3 over 2 divided by 1 plus negative a half. So I get root 3 over 2. And then I can't flip because this isn't a full fraction. What's 1 plus negative a half, guys?
4. 1 half.
1 half. So I get root 3 over 2 times 2 over 1, which equals root 3. And then a lot of people will stop here. Remember that you have to, at the end, say LS equals RS, or you're going to lose 0.5. Okay, do example 8 if you haven't done it. I'll give you a couple minutes. So, we have LS, RS. So I get 1 over 1 plus sine of pi over 4. Secant pi over 4 minus sine of pi over 4. Some people will say, well, I can take a secant out. I can just GCF that out. Makes my life. Are we allowed to alter anything?
No.
No, not in verification.
Or do they?
We're going to start it in proofs, and then you're going to start mix and meshing them. So you need to not mix mesh them. Verification, your first step is to fill in exactly how it is. Second step, numbers come into play, right? That's it for verification. Whereas our proofs today, where we can alter anything to make them match, because we're going to prove that it's left side equals right side without putting in numbers. Then it works for every value. This, we're only verifying that it works for pi over 4. Okay, so we get 1 over 1 plus root 2 over 2. So this is going to have to be 2 over 2. So I'm going to get 1 over 2 plus root 2 over 2. And now I have a full fraction over a full fraction because this is what it's over. And a 1 is a full fraction, so it's 1 over 1 times 2 over 2 plus root 2. So I get 2 over 2 plus root 2. And then welcome to grade 11. What did we do in grade 11? 2 minus root 2. We rationalized the denominator, and when we had a binomial in our denominator, we multiplied by the conjugate, which is same thing, opposite sign. Because when you multiply, and it makes sense, think about it. If you multiply by a conjugate, that means that your first term and your last term will stay, and your middle terms will cancel. The middle terms are the ones with the roots, so you want them to go away. So if I multiply this by 2 minus root 2, I'm going to get 2 times 2 minus root 2. I can put it through in a second. On the bottom, I'm going to get 2 times 2, which is 4. And then I get 2 times negative root 2 is negative root 2. 2 times positive root 2 is 2 root 2. And they cancel, correct? That's why you multiply by conjugates. And then it's root 2 times negative root 2, which is negative 2. And then this will become a 2. And then those will cancel. And then I get 2 minus root 2. On a diploma, they give you a lot more space, so we wouldn't be like squishy, squishy. Okay? Because when we look through diploma questions, if we go to do them and we're like, oh, you need to add more space, and it's too squished, they'll add more space. So there's never a lack of space in any questions, even multiple choice, you can answer fine. Okay, secant of pi over 4 is 2 over root 2. Do we want to keep it like that, though? I'm going to do it over here. Secant of pi over 4 equals 2 over root 2. Rationalize. And I get 2 root 2 over 2, which is just root 2. I'm going to do all the hard work off to the side. So I'm going to get root 2 minus root 2 over 2 times root 2 over 1 all over root 2 over 2. So I cannot flip that root 2 over 2 until my full numerator is a full fraction. Okay? So what happens in this numerator? I get root 2 minus root 2 times root 2 is 2 over 2, which is 1. Divided by root 2 over 2. Now I get negative root 2, or sorry, root 2 minus 1 over 1 times 2 over root 2. So if I want, I can go 2. That is a really large radical sign. 2 times root 2 minus 1 over root 2, and then I rationalize. So I'm going to get 2 root 2 times root 2 minus 1 over 2. The 2's cancel. And then root 2 times root 2 is 2 minus root 2. We match. That one's not an easy one. I'm not going to lie. So, yeah. When you're done writing that one down, we're going to flip past the next lesson and actually put it to two proofs. Page 10. Come back to that one. Yeah, we're coming back to that lesson after. I just don't want to teach it before your next unit test. We're going to page 10. Monday.
Oh,
Yeah. All right. Ooh, I got a little arrow happy there. Okay. Verifications, proving identities is what we did. Verifications is what we did. Now we're doing proving. Verifications verifies that for one number, left side equals right side. Right? Proving, we don't put in a number. So we prove that we can get the left side to match the right side without numbers. And if we can prove that, then we can say that every value that I fill in would get me an answer that works. So it's a proof, not a verification. So you split the equation into two parts, left-hand side, right-hand side, without the equation sign between them. Look for obvious substitutions using basic identities. So consider using the Pythagorean theorem identities. So that's like cos squared could get replaced as 1 minus sine squared, and sine squared could be replaced as 1 minus cos squared. People who do really well on proofs are the people who know what formulas are on their formula sheets. Simplify the most complicated side with the goal of making it equal to the other side. However, you may need to simplify both sides to get them to match. If necessary, write in terms of sines and cosines. So if I have like secant, I can write it as 1 over cos, right? Write expressions as fractions as a single fraction. So we need to get fraction over fraction so we can flip. Full fraction over full fraction, like we were just talking about in verification. Look to divide out common factors, so like crossing off 2s, or like we did in the verification. And then multiply the numerators and denominators by the same expression, possibly a conjugate if necessary. So an example might mean, if I have 1 minus sine x, and I don't have any clue what I could do, well, I could actually multiply by 1 plus sine x, because when I FOIL that out, I get 1 minus sine x plus sine x minus sine squared x. Correct? These cancel, and I'm left with 1 minus sine squared x. And what does 1 minus sine squared x equal? I hear people whispering it. Cos squared x. So if you have a 1 plus sine x, 1 minus sine x, 1 plus cos x, 1 minus cos x, you might think, would a conjugate help? But it's only those ones. Okay, these are all information. There's no like, do this and it will always work. Hence why verifications are easier than proofs. Verifications, you do this, it works. Proofs, you might come up with it in a totally different way than someone else. So let's look at these ones. So we have 1 minus sine squared x equals sine x cos x cotan x. So our first step is to write ls, rs. And then I get people doing this. Oh, 1 minus sine squared x. Well, that's cos squared x. Should your first step be altering what you're trying to prove or proving what you're trying to prove?
Proving
Proving what you're trying to prove. So you actually have to rewrite the proof. Correct? So our first step is to literally rewrite it. Left side in itself, right side in itself. Do I fill anything in for x? The moment I fill something in for x, you've completely destroyed the proof. Because a proof, you get the left side to equal the right side without any values in your x. So if the left side equals the right side without any values in your x, that means I can fill in any x and get an answer. Unless there's MTBs, which we'll talk about later. So, what could I do? Anyone have any suggestions?
simplify cotan into cos over sine.
Yep, so I could go sine x times cos x times cos x over sine x. The moment I get fractions, I make the rest of them fractions as well. You cancel the sine x's off. What am I left with? How do I write that though? Cos squared x. Cool, I've halted. So now, I could do one of two things. I could keep going on this right-hand side and say cos squared x equals 1 minus sine squared x, and they match. Or I could go to the left-hand side and say 1 minus sine squared x is cos squared x, and they match. So at this point, you could do either way, right? So I could go, okay, well, this equals 1 minus sine squared x. And now my daughter, who's in grade 4, can confirm that these pictures are the same. She doesn't know what a sine squared x is. She doesn't even care. I would say, hey, London, can you tell me, does this one and this one match? And she'd be like, yep, they look the same. That's what you need. You need some random human who knows nothing about anything to be able to come up and say, yep, those pictures match. Okay? So ls equals rs. Could I have instead not put the 1 minus sine squared under the cos squared and change the 1 minus sine squared to cos squared and then say they match? Yes, you could equally say that's the same, right? Yeah. So what they might do on a question like this is it might be here, prove this, and then your next bullet is determine the restrictions or the non-permissible values. Yeah. But if it's not asked, you don't have to. All right, we're doing restrictions after this though, so we're not going to do them now. We'll do them after. Okay. So here we have tan x cos x divided by cos squared, or cos secant x equals 1 minus cos squared x. So our first step is a table with LSRS, and then we write tan x cos x over cosecant x 1 minus cos squared x. Work on it as a team. See how you do. All right.
It would be so funny.
Okay. So, tan x can be written as sine x over cos x times cos x over 1. And then that's divided by, well, that's an eraser. It's not divided by at all. That is divided by, I like using a different color as my division that separates my fractions, like separates my numerator and my denominator so that I don't, like I actually have a little bit of a split. So for me right now, I know that blue line splits my numerator and my denominator, and until I have the full numerator and a full denominator fraction, I'm not allowed to flip it. So I like using a different color personally, but you can do which one. And then I get 1 over sine x. Now the cos x's can cancel, and I'm left with sine x over 1 divided by 1 over sine x. Now do I actually have to show sine x over 1 divided by 1 over sine x, or could I do this? Could I skip that step and just go to multiplying? Yeah, could I reason in my head watching you, could I go through this and be like, okay, they took the sine x, okay, they flipped that and multiplied. Yes, I can reason that that is a reasonable jump, okay? If you went from here, this one with the blue lines, to sine squared x, no. That's not a reasonable jump. You just show a step in between. Because why? Because we don't know if you're the kid who can get hundreds or you're the kid who has 30s and you're just sending it at this point. You're like, I don't know what to do. I'm going to write sine squared x and hope they get it. So if we can't decipher between the two, if you're just sending it or if you actually know, then you won't get the full marks. Okay? So show this middle interim step and then go sine squared x. And we do ls equals rs. One side put sine squared x. Could I have done nothing on the right-hand side, turned this to 1 minus cos squared x and said left side equals right side? Absolutely. Okay? All right. Go. So we get ls, we get rs. Some people are like, tan, sine x over cos x. Do you see how you could accidentally oops and start working on the problem before you wrote the problem?
Yeah.
Did you know that immediately you get a 0? Because you're not proving the proof they gave you, you're proving an altered something of which you just made up. Do you know what I mean? Like if the proof is tan x equals that, and you're like, okay, I'm going to prove that sine x over cos x equals, you've just completely proved a different proof, correct? You've not proven the proof that they gave you. So everyone, triple, double check, and I'm going to say this over and over and over, that you are writing the question first. Yeah?
So if you put the, like, let's say you weren't paying attention and you said ls was 1 minus cos squared x, or cos 2x over sine 2x on the left side, like you put that one.
I've never seen someone do that, but if they did, I can't, I don't know. They'll probably take off some sort of a mark just because they say, they'll basically say that that's not perfection. You didn't do perfect. So like if it's perfection, you get a 3 out of 3 or a 2 out of 2. If it's not perfection, you would get 0.5 off. So they'll say, oh my goodness. They might, I don't know, they might like discuss it as a big group and be like, wow, this kid's an idiot. Why did they put him backwards? And now we have to have this discussion and decide. And then they'll be like, you know what, the kids did everything else right. They're not that stupid. We'll just give them a 2 out of 2. I don't know how the discussion would go because I've actually never seen someone do that. That's impressive, Sam, if you have. But if they did, they might discuss it. He had it. He's fine. I saw yours. Yours was really good. So you had it right. But if they did, I think it would probably be a discussion of like, oh, that sucks. Let's give it to them. But I can't say that it for sure would. If it were me and I was marking your test, I'd be like, oh, dorky dork. And then I would just, and then I'd have a discussion with you, and I'd probably put a sad face with tears in a puddle. But I'd probably say okay. So left side is tan x, but you did it right because you had that on that side anyway. You just asking, and you flipped them. I get it because they were the other way.
Yeah.
1 minus cos 2x over sine 2x. Okay, I'm going to work on the easier side in my mind. So I have 1 minus cos 2x. Now some people will be like, I don't know what I should pick. Okay, well, if the other side is super complicated, I might reduce the easier side to see if that helps me, gives me like a little inside scoop as to what I might need. So tan x to me is sine x over cos x. So I know in the end, I'm actually going to need to get rid of everything. Because I need a cos x on the bottom and I have a sine x. And I need a sine x on the top. Correct? Yeah. Yeah, look at that. I would have got a 0 right off the bat. Would they give me a sympathy 0.5 because I wrote it wrong? I don't think so. That would have been terrible. All right. So I know on the bottom here, I have 2 sine x cos x. We agree? And they're all being multiplied. 2 sine cos. And multiplication comes with that whole realization that if 3 times 2 is the same as 2 times 3. It's like commutative property, right? They can be moved. So 2 times sine times cos could be 2 times cos times sine. It could be sine times cos times 2. Like I can move them all around, correct? That also means that they're standalones. The 2 is by itself, the sine x is by itself, the cos x is by itself. They're all being multiplied. So because when everything is multiplied without a plus or minus sign, they stand alone. So this is a monomial on the bottom, correct? If it's a monomial, do you see it's a monomial? So adding something is a minus something is a monomial. Monomials can go in their own brackets. Okay? Then I need this I need the sine and the 2 to get out of my life. So I have options with that cos 2x, and I want to get a sine and a 2 to cancel off. We agree? So what would be my best cos option? To keep a cos squared, would that cancel off a sine?
No.
Cos and a sine? No. Maybe the 1 minus 2 sine squared? Because that is a 2 and a sine. I need that to get out of my life. So a lot of people go 1 minus 2 sine squared x. And then they run into trouble. Remember, you're subtracting both of those terms. We agree? So that minus sign has to go in through both of them. So I'm going to get 1 minus 1 plus 2 sine squared x over 2 sine x cos x. And then what can happen? The 2 can cancel because it's a monomial. The sine can cancel off one of the signs. And I'm left with sine x over cos x. Okay, look at example 4. Isn't it pretty? You're going to have to do it for homework. Then example 5. Let's look at example 5. It's all sines and coses and all singles. I can't really do anything. What did I tell you might be able to do, though, when you have a 1 plus sine or a 1 plus cos or a 1 minus sine or a 1 minus cos? You can multiply by the conjugates. I'm going to give you a hint on this one. 1 minus cos x over sine x. And then I get sine x over 1 plus cos x. So I can either take the 1 minus cos or the 1 plus cos, either one. I'm going to go 1 minus cos x over sine x. And I'm going to multiply by the conjugate. 1 plus cos x. I'm not going to do it to both sides or you're just creating chaos. The key thing when you multiply by conjugates, paying attention, is I need, do you see this sine x here? I need it to get out. Do you see how I'm multiplying by this conjugate? I need the sine x to go away. We agree? Because this has a 1 plus cos x, this will now have a 1 plus cos x. Do you see that? Mm-hmm. But I need the sine x to go away. So if I distribute the sine x into this 1 plus cos x, am I making it better or worse?
Worse.
Worse, because I need this. This is my problem. This is my little problem child, and it needs to get out of my life. Okay? I don't want to embed it with my good child. Now I have 2 bad children. That's a problem. So you always multiply the conjugates together, but you never multiply the ones that are not conjugates together. Because I need this sine x to go away. So on the bottom, I'm going to have sine x and 1 plus cos x. And on the top, in the numerator, what am I going to get? Well, 1 times 1 is 1. Then I get negative cos x, positive cos x. What happens with those? They cancel. When you multiply by conjugates, your middle terms cancel. That's the point of multiplying by conjugates. And then our last term, negative cos times cos, is negative cos squared x. Guys, what's 1 minus cos squared x the same as? Sine squared x. Now, do you see if I embedded, John, do you see if I embedded the sine x in, I wouldn't be able to fix the problem? I look at my right-hand side, I need a sine x over 1 plus cos x. Oh, cool, this sine will cancel off this one, and what am I left with? Now, some people say left side equals right side. I promise you my daughter in grade 4 does not know that those match. Okay? Your next door neighbor, if you brought it over, they'd be like, yeah, those do not match, if you asked them, unless they're a math teacher. And then they'd say, do another step. So we get sine x over 1 plus cos x. And now we can say left side equals right side. All right? You're going to try example 6 tonight too. I'm going to give you a hint. Both of these contain a secant x, so perhaps you can GCF a secant x out. That's your hint. Example 7, good luck. And then you're going to try example 8. A hint for example 8. This here is a what? What is this?
Square thing.
Difference of squares. So you're going to get a 2 sine x, 2 sine x plus 1, and a 2 sine x minus 1. What can I GCF out of here? Cos x. If you get stuck, it's totally fine. Just try it out. If you get stuck, get stuck. Or just try it out. Because I could stand up here and do proofs for days. You're like, oh yeah.